And yeah, so the talk is about Scala.js, and the thing is, who already played a little bit with Scala.js? Also, a lot of you. So this is, if you already deployed something on production with Scala.js, probably there will be nothing new for you. So just a hint, it's mostly for those that are not convinced that it's cool, because it's cool. It's really great project. And about me, it's just, this is the mountain. It's made dark, but it's really nice one called Pilatus. Where I live, basically, not on the mountain because there are dragons there, but just below. And I am developer, wizard, and an architect. I spend a lot of my time at work with Java, and sometimes with Scala, and with JavaScript and CSS. I'm a real CSS hacker, by the way, so basically if you want to see that CSS is almost Turing complete, I can show you that. But yeah, if I have free time, I like to play with Commodore, and because this is the real part that it's not boring. Okay, so my Pokemons, like this is the things I do, but I work for a company called Ingenious. Then we basically do consulting and fun stuff for banking. We try to bring some fun and to the places that are not that typically fun. Okay, and in my free time, I like to ride around this lake on my bike. That's cool. Okay, so for today, quickly, I will first try to show you why it's cool. So why Scala.js at all? And then will be how it works very quickly, so that you see it's easy to use that, and some experiences from the projects I did with Scala.js. And then maybe even a comparison, because there are a couple of projects that are very similar or alternative to Scala.js that you also might consider. Okay, so the business case, the first time I tried to do something with Scala.js was this. There was an insurance company, and we wanted to do something cool, where the user, using his mobile device or something, will be preparing his, will be just basically counting his insurance for a lot of stuff like car, house. And the thing is, this application was designed to be quite fancy with a lot of sliders, not like them, but more or less. You can imagine, you have sliders, you change some parameters, and basically you should see as fast as possible how much would you pay for such insurance, if it makes sense. So the thing was, counting these quotes for insurance, it's not very complicated, but you can do that even on a client, even in JavaScript, but it typically needs a lot of data, insurance tables. So the thing, what we wanted to do is to do that client-side, but then we were not sure if the amount of data wouldn't kill the device. So maybe we wanted to do it server-side, where for sure it wasn't a problem, it was always like that, but then, for instance, our users do a lot of stuff while being in a train, in a tunnels, and they don't have a good communication with servers. That would basically kill the user experience if for every change on a slider, the server would be responding like in half of a minute because there was temporary problem in the network. So basically, we knew what to do, but we didn't know which way is worse. We wanted to be flexible, like maybe if we see this is worse, this is killing the users, maybe we'll stay on a server. But maybe it's better to go to the JavaScript part, and maybe it's even better to, after 5 seconds, after all the data was loaded, to do calculations on the client side and leave the server. So there were a lot of possibilities. We wanted flexibility. And then that's how we found out the Scala.js. So let's just do this once in Scala, and then deploy it or try it in any place. And we'll see that during deployment, during the tests, we'll see what's the result. Actually, I can even tell you that we finally, for some calculations, we did everything client-side, where the data amount wasn't that huge, and some calculations were done server-side, because they needed. Sorry for that. It's not me. Oh, okay.
1111.
Okay. Okay, so my battery is somehow not that good anymore. It's late. Okay, so the thing about JavaScript. The thing about JavaScript is, I like this quote. Nobody basically chooses JavaScript. It's like it happens to you. There is a moment you have to do something in JavaScript, and basically, I can recommend you one thing. This is a horrible language. It's easy to make fun of this language. There are even cool videos. If you haven't seen this, JavaScript, this is Destroy All Software Talks. I really recommend this video. This is 10 minutes of fun with JavaScript and all other stuff, but it really concludes how ugly the language is. But the thing is, it really pays off to learn it. It's horrible, but if you write even a couple of lines with JavaScript, it pays off just to spend some time, maybe a couple of days, reading the books, how it works. Because then we'll be at least knowing how bad it is. Okay, so I did this in my life. I learned the JavaScript, and I found out that, for instance, there are things that are, this is a very famous picture. I didn't want to make it big because it's like appears in every presentation of JavaScript, the good parts. The book on the left, the thin one, is the good parts of JavaScript. As you see, it's not that, not everything in JavaScript is good. Not many people know that the author of this book made further talks with the name Good Part Reconsidered, where he says that even in this book, good parts, some parts he doesn't consider as good anymore. So this book right now would be very, very thin. So it's horrible, but okay, it's like this. You have to accept that, but on the other hand, the HTML, the web, basically those things are great. The user experience you can provide with single-page applications is just great. The users love it, even I like it. So and the tools for JavaScript like Gulp, NPM, they are not as bad. Really, they are working quite okay. So frameworks, especially for instance, if you haven't heard about Meteor.js, it's a really cool framework. So they are quite innovative. So one thing about JavaScript, some people love JavaScript. I even realized why. Because you do something and instantly you see the result. It's something, if you worked with, big Scala project with Scala Z implicits, you really miss this. It's like, you don't have this, like 2 seconds and you see the result. So this is cool in JavaScript environment, mostly. And sometimes I even thought, oh, I'm so efficient with this JavaScript, and people are so efficient. Maybe this tape saved we are thinking about, it's not that important. We just do more tests and it's all okay. But nevertheless, I would say it's finally, whatever you do, you just have no satisfaction with this JavaScript. It's never, ever finally good. It just works, it's okay, it has good parts, but it's not as funny as Scala or whatever else. So there are solutions for that. And my solution, oh, sorry for this sound. My solution for that I found was Scala.js, and we'll just try it very easily. I won't be doing anything complicated today because we've seen complicated code. It is a basically hello application for Scala.js, and maybe to just show you that I am doing something for real, it's a real coding. Hello, Scalar. Yeah, now you see the real code. So what has happened here? There is a server behind that transpiled this Scala code into JavaScript. JavaScript was run in the browser, and you see the result. How cool. So this is nothing that complicated. I will show you something more funny later. But this is the idea, how it works. So this is Scala.js, what we have. And basically, Scala.js is Scala to JavaScript called transpiler, compiler. So JavaScript became some kind of a bytecode or assembly of this. More or less, it's like a bytecode. And good thing is that it works on anything that runs JavaScript. It means it doesn't have to be run in the browser. Oops. So basically, it may work wherever you think JavaScript. So on Node.js, there are people that really are transpiling Scala to JavaScript and running on a server with Node.js. I can't imagine something more crazy, but people do that. Unfortunately, because of the resolution, that is how one of the transpiled functions in Scala is looking in JavaScript. Maybe I can do something with that. You see, you see a lot of code. Now maybe why I'm showing that, because this is the actual code of this function. You see it's a lot of produced. But it's Not that bad. It's typically, if you compile to simpler language, you have more instructions. It's like this. So, and as I said, it runs basically everywhere. So there are people that run it, for instance, also as plugins for some programs where you can program do some plugging or whatever in JavaScript. So cool stuff about it. This is just Scala. It supports all the syntax you have in Scala, including, as it's here said, Scala. So you don't have to learn anything Scala-like language or something. It's just Scala. So the only thing is that it runs in a different environment that typical Scala project runs. So good part, it works with SBT. So you know SBT, you know how to play with ScalaJS. And great thing is integrates with existing JavaScript ecosystem tools. I will show you that quickly, describe you, because that's probably the most important thing. And I won't be just showing everything about ScalaJS, because there is a great page with tutorials, everything. You can go there. The ScalaJS has its heroes. Basically, the authors, really, they do a great job for that. You can read a lot. They explain how they did things, what were complicated parts, decisions. This is also interesting part to read that if you are interested, for instance, in compilers. So about ScalaJS, now I have to show you something, how it integrates with JavaScript, with browser, for instance. So maybe, may I use this microphone? Okay, because it's for me now complicated, because I would love to make it, help me. Okay, so I'll be doing some coding, now the real part. So that's great. So I want to use jQuery, because you know that the best library in JavaScript is jQuery, of course. So if I'm going to use jQuery, what can I do? I can just, write something like this. There is a jQuery object somewhere, and it has one operation with a selector. I create something like that. Okay, this is the basic definition of jQuery main object. But it's not all that we want to have. So maybe we would like to have something like, why are you laughing? It's just coding. Haven't you seen live coding? So this is the jQuery append. I'm only defining the operations that I will be using. So I will just define this. This returns the same object. Okay, so I will have it now. Okay, so I'm going to use that. So maybe, just to make it easier, I will write it just to not, this is ScalaJS, of course. And maybe I will run it very quickly. Let me show if it works. Okay, this is ScalaJS. So I will define with using jQuery that body object is this. Okay, it's easy. You see the code, okay? Just a moment, I make it above. So now I will define something like ScalaJS div. It's the jQuery, so it's as if I was doing that with jQuery. Okay, maybe, sorry, just a moment. And position absolute. This is something nasty I'm trying to present here, but I just don't want to spend too much time on doing nice stuff. It must be visible. So, by the way, it all runs in the browser. This presentation is a browser, so I'm going to spoil my presentation changing the divs while running this code. Because that's crazy. So basically, I will just append this div. Why not? That should be ready. So somewhere above should, you see that? It appeared this is ScalaJS div. You don't see that good, but maybe position absolute. Okay, if I put something like top 50 pixels, it should be better right now. Now I will have two divs. You see that? So I'm basically destroying my presentation in a browser with this code. But luckily I can fix that, because jQuery has operation, which is basically removing of elements. So I defined that I'm basically gonna use this operation, okay? And now let me maybe remove this element after a couple of seconds. So I will define this. Document is DOM document. I have this DOM document because I've imported it here. So you can also, there are already existing libraries you can use. This one provides DOM operations for me. And I'm using set timeout. You see, it's even very similar to the TypeScript or new ECMAS syntax. And after 2 seconds, it should be removed. So basically, all my diffs now should be removed after 1, 2 seconds. And it's gone. So I fixed my presentation. As you see, it's very easy to use something. And if you have some library which has some functions, you can provide binding on your own. Most of the time, you don't have to do that because those bindings are already created for you. So there is, and if you go to the Scala.js page, you just see that they have bindings for everything from jQuery, Scala.js, 3JS. It's a lot. I didn't have time to write. Those are the things that I played with mostly. So also for frameworks like React, Angular, there are a couple of bindings. So if you have framework, it's more complicated to do a binding for framework, so you'd better see if there is something ready, but there are a lot of them. So, but there is other part. There's also Scala libraries that are existing libraries that can be used in the browser easily. Because if your library is using something like I/O, files, even temporary ones, it can't be really used normally in Scala.js. But a lot of libraries at the moment are cleaned in a way that you can use it without any problem. And it, for instance, this is the ScalaZ, for instance. Cats, as I remember, it's also available. So a lot of libraries that do pickling and basically even Scala tests. For instance, great thing is I'm doing that. I'm writing services components for the browser, and I have tests written with Scala tests that I test with JVM on the JVM part, and only sometimes I'm running it in a real browser, running the Scala test inside of the browser. This is cool. It works great on the CI. And the thing is, there is even this project, Akka.js. So this is not really cross-compiling. This is the experiment to basically port Akka to JavaScript, to Scala.js, and it works. This is a cool thing. So, of course, it's a little bit limited. So how it works, it's basically you just add this plugin to your SBT, you enable this plugin, and then you have more targets like fast.js. What does it mean? Create me, please, SBT, JavaScript, as quickly as possible. So you use that mostly during the development. In fact, you use it this way. So and if you use this way, while you type, you will be having continuous compilation, and you will be seeing the changes in JavaScript in 1 to 5 seconds, which is cool because it's almost as cool as with normal JavaScript, so you don't wait that much. Typically, if you do productive development, you do something called full opt.js, which basically takes your JavaScript and tries to minimize it, make it optimized with something called Google Closure Compiler, so that it's very minimal and fast. Basically, the minimalization is the goal. However, oops, just a moment. The thing is that after minimalization, just a moment. Okay, after minimalization, it's still not that totally tiny. I think it's like 100 kilobytes for real projects after zipping. So that's how so this JavaScript, if you use especially ScalaZ or you use a lot of Scala collections, you should expect such sizes. It's okay, but it's not tiny. So that's one of the things. However, even for mobile devices, we didn't see that problem that big. It wasn't a real problem, only maybe for very, very old devices. So the greatest part about Scala.js, it's really, for instance, if you see some solution on Stack Overflow written for JavaScript, it's easy to convert it to Scala.js. You've just seen it with jQuery. It's great thing is that if you have developers that worked for ages with Gulp, Grunt, whatever, they can easily work further this way using Scala.js because it just produces one JavaScript that you can put into your build for JavaScript things, for Gulp. It's typically quite easy to use JavaScript frameworks. I used Angular and React. For React, it was very good. For Angular, it was okay. It wasn't perfect because the binding for Angular is not that perfect, but it's still usable. I am talking about the old Angular. The new Angular, I have still doubts if this binding that is already provided, it's really usable. I would say not that cool, but who cares about Angular? Okay, this is the interesting story. So the code produced, it's quite fast. I will show you some benchmarks. Cool thing is that debug works. So really, this is the I'm not sure if you see that, okay? Again, the problem with the, okay, I can't show you that, but basically you debug Scala code in the browser. How cool is that? So I love it. It is basically because the browser supports maps and ScalaJS produces you something called map files, which basically says which JavaScript comes from which Scala source. So this is a great thing. And ScalaJS ecosystem really grows steadily, so it's like there are more and more libraries and things that you can use. And this is the thing I used, so you can test and debug on JVM and then run on the browser. And you can share the code. This is the real stuff. I will talk a little bit more later. And type safety. So finally, that's the best thing. That was the really moment I've seen, oh, this is awesome. Because I was doing some project for a month, and then I realized I need a bigger refactoring. And in my mind was, oh, you never do refactoring on the front end because it's horrible. No, with ScalaJS, it's just a refactoring of Scala code. It takes maybe 2 days because nothing compiles, but in the moment it compiles, it works because you have types. That's a cool thing. So it's completely changed the way I'm thinking about front-end development. So ScalaJS performance, there are some benchmarks. So basically it's slower than JavaScript, maybe 50%. There are some cases where it's 3 times slower, but it's not bad. So it's acceptable. It's in the real projects you don't see this slow down that much. So this is the maybe example just for you. This is the fractal written in ScalaJS, and what I did, I basically took a JavaScript code and line by line adapted it to be ScalaJS code, which was very easy because even if you look at the syntax, what you do, you change var to vals, and you change the for loop, and it's that. So this is the fractal. It took 2 seconds to draw it. Now the funny part, next screen is the original JavaScript code. You see it's even similar, and I run it, and now I have a lot of time. Nothing works, basically because now it isn't sent to the server to compile it to the JavaScript. It's directly run in the browser, and we wait, and we wait, and we wait. So in this case, the JavaScript code is way slower. Actually, I would say it's not expected results. There is a reason for that because I'm calling this in an eval. And somehow, nowadays, the browser, I'm not sure, maybe this is the security thing. This is the security thing, but if you call a bigger code inside of the eval, it takes a lot more time than calling this code directly. If I would run it directly, the JavaScript would be a little bit faster than ScalaJS, but it's really, they are really close. So about ScalaJS problems, because not everything shines, I told debug works perfectly line by line. But if you look at the objects that you see in the debug, what you have in variables, they are just, you see a lot of dollar signs, but not typically the data you wanted to see. So it's like the format of the object is totally different. You see just internal ScalaJS objects. You have to learn and like Scala. For you, it's not a problem. You were on Scala conference, but I worked with teams with people that were not the Scala fans, and it was a blocker. Because they just told me, like, we love JavaScript, and this Scala, it works, but we don't trust it. So it's like, you have to be aware of that. Some people just don't like Scala, don't want to learn it, and you shouldn't force them to use ScalaJS, probably. Wrapper libraries, not every perfect, like Angular, for instance, isn't that good, and I am good at JavaScript. So if I have problem, I can solve it. And basically, if you are using ScalaJS for productive things, you should be prepared to have some JavaScript guru. Otherwise, if you have problem, I'm not sure who can help you. Basically, I don't really remember anything very horrible, like maybe with memory or something, but I wouldn't say at the moment you can just fully go Scala.js and forget about JavaScript. I think we are not yet there. So maybe in a year or two. And of course, now, if you think of what code runs, you do something with threads, I/O, don't expect it will be fully working. Some things will work. Of course, if you do something like await result, who loves this code? It wouldn't work with JavaScript, because the way the JavaScript works. Runtime reflection isn't supported at all. That is probably the most important decision of the guys that written the compiler. But after all, I think, is it actually that bad? So because of that, a lot of libraries, even in Scala world, they just basically skipped runtime reflection. They dropped runtime reflection, now they use macros, which is better because you have this stuff done during compilation time. So, but you have to be aware of these limitations. What is cool? Sharing the code between client and server. So you define your case classes, you define your API. I didn't use the endpoint project that was today described, but it looks like perfect fit for that. So you can define in one place as validation that will be used in a client and browser. We did it, that's cool. You can even, to some limit, use concurrency stuff with futures and things like that, but you have to, you need two different implementations behind, but it works. So there are some libraries that basically have different implementations for browser and different implementations for JVM, but one API so that you can use them on both sides. And cross-compiling libraries, so there are, for instance, logging is such case. So how you do that in the real project? Typically you have shared code in Scala. Those are APIs, validation, and all that stuff. Even in some projects, a lot of business logic. Then you have JavaScript part, which maybe it is React code, so things you would do in React.js. Then you have JVM part, which is reusing the API definition, but now you have maybe akka HTTP or something like that. Then you have SBT. SBT produces JavaScript code, which is then normally applied to the normal build process for Gulp. SBT produces jars for a server. Then you can even debug it and use it in development with something called Gulp proxy. It's really, it's perfect for development. I have this thing that I just write my Scala code in a second or two. I see the changes on the browsers. This is really cool because you typically don't want to, you know, change a position of button and wait 3 seconds till it appears in other place. You want to see the changes immediately. So it does it. So alternatives to, because I'm going to the end, alternative, the most viable alternative to Scala.js is TypeScript, which is basically JavaScript ++, I would call it. It's very simple. Some other alternative, if you love Haskell, it's maybe PureScript. So I never played with PureScript for real, but it's, I would say there are similarities between PureScript and Scala.js. And Elm is also a Haskellish syntax, but it is more pure, I would say. So if you want to see the differences, this is like TypeScript. If you think of a JavaScript being a cat, TypeScript is just you put a mask, but there is still the same cat behind. So all the bad problems are inherited. This is how Scala.js cooperates with JavaScript. They are just good friends. They accept all the problems. Scala.js accepts all the problem of JavaScript, uses them. It's just nice cooperation. This is how Elm works with. So Elm basically, you know, if you use Elm, you don't use Angular or React. You just forget about everything that it's in JavaScript. You have your own framework, which is cool, very similar to React, but you just don't look at JavaScript at all. So maybe you want the purity. Who knows? So for the biggest competitor is TypeScript, and I would say like this is this. It's superset of JavaScript, so it inherits all the problem, but TypeScript is very easy to learn. For the junior developers that only know JavaScript, forcing them to learn Scala is a strange thing. It doesn't work, basically. Facades, so bindings for JS libs in TypeScript, basically every sensible library has a mapping for TypeScript. In Scala.js, mostly all the popular have bindings, but some are missing and some bindings are not really great done. Type safety in TypeScript is just optional. In Scala.js, you know how cool is that. compiler, of course, and yeah. The coolest feature, I would say, why I would choose that, coolest feature of TypeScript is Angular. It's really productive. You may laugh from Angular, but it's really productive framework, efficient. Coolest feature of Scala.js, in my opinion, is refactoring. Once I've seen that, I really loved it. And then, yeah, most ugly thing is JavaScript insertions or Scala, things like that. And because I'm at the end, this is my email. If you have any questions about it, want to talk about Scala.js, I have some productive experience with that. 2 years ago, I thought Scala.js is a total game changer. It gained some interest. There are a lot of projects using that, but it didn't won. There was no really Scala.js revolution and nothing like that, but it has active community. You can use that. At final message, please end with JavaScript. We have 2018. You can use TypeScript. You can use PureScript, you can use a lot of stuff. You can, of course, especially you, use ScalaJS, but please don't do that to yourself and to your colleagues with JavaScript. We end it. Thank you.